Section 3.8 Implicit Differentiation. For this problem, we need to find the second derivative. So you will have to find the first derivative implicitly, and then you take the derivative again implicitly to find a second derivative. And the point of this problem is not really, it's just to make sure you can handle complicated and repetitive calculation accurately. So for the left hand side, we get derivative of x, which is just 1, times cosine of y because of the product rule, okay, plus x times derivative of cosine of y, which is negative sine of y. Because of the chain rule, we gain a factor of dy over dx because y is a function of x. So that's the left hand side. Right hand side, we get negative 5 times dy over dx. So now we need to combine like term and solve for dy over dx. So we can move this term to the other side and change the sign, and move this term to the right hand side and change the sign. So when we combine like term, we get 5 minus x times sine of y. This is the coefficient for dy over dx, and it will equal negative cosine of y. Now we solve for dy over dx. We will get negative cosine of y, 5 minus x times sine of y. You need to keep note of this expression because we'll need to use it again when we take the derivative implicitly. We will gain a factor of dy over dx on the right hand side. So now we continue to take the second derivative. So dy over dx will equal, according to the quotient rule, so we will have 5 minus x times sine of y square times, so on the top we get derivative of the top function. So derivative of negative cosine of y is sine of y times dy over dx, and we need to multiply by the bottom function, which is just 5 minus x times sine of y. And then we need to subtract the top function times the derivative of the bottom function. So we get plus cosine of y because negative cancel, okay, times the derivative of the bottom function. So derivative of 5 is 0. Derivative of negative x is negative 1, so negative sine of y minus x times cosine of y times dy over dx. Okay, so that is the top. And if you just substitute dy over dx, you'll be done. Okay, but we can simplify it a little bit. So we can see, okay, sine. So take a look at this expression, dy over dx times 5 minus x times sine of y. That is just simply negative cosine of y. So that we get negative cosine of y, sine of y. Okay, so now we distribute the cosine of y, so we get negative cosine of y times sine of y. So we can combine with the first one is negative twice. Okay? Cosine of y times sine of y. So now you distribute the next one. You will get negative x times cosine square of y. dy over dx you have to substitute, so negative cosines of y. 5 minus x times sine of y. And in the bottom is 5 minus x times sine of y square. Now you can stop here, but we can simplify a little bit more, okay? So we will multiply top and bottom by a factor of 5 minus x sine of y to simplify it a little bit more. So 2 became 3. So now you get in the bottom is 5 minus x times sine of y cubed. And on the top, you get negative 2 cosine of y, sine of y, and it's the same as sine of 2y2. But we don't need to go through that. Okay, so times 5 minus x sine of y. And then for the next term is just plus. Okay, these two cancel, so you get x cosine cube of y. So this should be the equivalent correct answer. And there are other ways to simplify it, and you can use other trig identity, but this is basically equivalent to all the other answer that you would get. And how the computer could evaluate it is the computer will evaluate xy value that satisfy this equation. And it will plug it into the dy over dx, or the second derivative, into this expression. And if the numerically it agree, then it will assume the expression is equivalent. But if you have any question, you can always ask me. I will be able to follow your procedure and see whether it's a correct answer.